All right, everybody, welcome on in. So today we're discussing polynomial multiplication. So we aren't going to have time to get through polynomial division, but I think if you watch the videos, you should be fine. I think watch the videos, you should be able to pick it up. Polynomial division is just kind of the same procedure every time, and it's sure, it changes slightly from problem to problem, but once you get the idea, students are usually able to get through it just fine. So I think I'll leave that one up to the videos. Feel free to come to office hours and stuff like that if you have questions. Otherwise, I'm going to get into polynomial multiplication, which I find is a little more confusing for students. They're more likely to get mixed up about things. And part of this is because some of you have taken polynomial multiplication in the past, and your teachers taught you sort of neat tricks to get you to remember how to do it, but then actually overcomplicated the situation quite a bit and made it much harder than it needed to be. That's my opinion. Some people might disagree, and I'm not saying every teacher does that, but I've definitely, this is one topic where I think, like, man, I see stuff coming out of schools where students come to me with stuff, and I just think, wow, you learn this in a way that is so much more complicated than it needs to be. Like, it just doesn't need to be that hard. If you can think about it in general terms, you're good. And part of this is the difference between, which, you hear me talk about this a lot, just coming into a math class and trying to memorize everything. I know a lot of you have been trained to do that in your years in the K-12 system. It's not what we're supposed to be doing anymore, but people are still teaching that way, where come in, memorize this, and then you're good to go. But that's not really learning math. And the reality is, when you memorize those things, you forget them. Within a year, you'll have forgotten all of it. So what I'm going to try to teach you is the general way of thinking about polynomial multiplication, and then show you how you can apply that general thinking to any type of polynomial multiplication that you run across. Okay, so, like, we have a very specific situation called FOIL. I'm going to show you how FOIL actually meets our more general definition for polynomial multiplication. And when you understand the underlying mathematics behind polynomial multiplication, most students go, oh, I get it. It's not, yeah, okay, I see. I can deal with any polynomial multiplication problem you give me, and I'll be just fine. Okay, so we'll go over that. Students tend to get pretty good at it. Now, here's what I'll say, is I'm going to show you some stuff, and it's very natural, if some of you have seen polynomial multiplication before, to go, wait a minute, I had a teacher show me this other way to do it. And that's probably true. I just kind of complained about that a little bit, that a lot of the ways that students are shown, I think, are not great. But what you want to understand is, even those like complicated ways that, your teacher may have had a little mnemonic to help you memorize and remember how to do it, or fancy little ways of organizing your work. And there's the box method. There's one called the Chinese method. There's all these different versions of how to do these kind of things. They're all really the same thing. Right? It all comes down to, if you just think about the polynomial multiplication from the perspective I'm trying to give you, which is the definition we'll look at in just a little bit here, you can apply it to all of them. So don't, like someone, okay, I see how you did it on the board, but my teacher taught me to put it in a box. If you take the way that your teacher taught you to do this before, and then you look at the way I'm showing you, what you'll see is it's the same stuff. The same terms are showing up in both. You can track both things and go, oh, this term's here, and then over in his example, it's here. And you can see all the same exact things are taking place. The only real difference in these methods is the organization, right? So there's the box method, where you organize all your work in a box. There's, like, a diagonal method, right? There's a method they call big X method, but that's for factoring, actually. But I've seen one where people have, like, an X, and they do these different things, and they'll say, see, my teacher taught me a totally different way to multiply polynomials, and then I'll explain, actually, it's the same, because look, here you got this term, here it is in my work. Here you got this term, here it is in my work. So if you've seen a different method before, it's just a different way of organizing your work on the scratch paper. And if that works for you, use it. That's totally fine. But what you should understand is, you're not really doing anything different than what I'm showing you. You're just, it would be like saying, people are doing different problems because their scratch work is different. You're still doing the same stuff, right? You're still doing the same multiplications. You're still using the same rules of exponents. You're still following the same basic procedure. You're just writing your scratch work a little bit differently than other people are. So that's one thing I just want to kind of hammer home, because I almost 100% of the time after I teach this section, someone comes up and says, no, my teacher taught me a totally different way to do this. And it's like, it's not really a different way. You're just putting your stuff in a box, which is fine. If the box helps you organize your work, do that. If the X helps you organize your work, do that. Just realize we're all doing the same work, okay? So here's a couple things I want to review. Couple things, really real quick, a couple things we're going to need to know. Remember, we have a rule of exponents that says x to the n times x to the m equals, do we remember our rules of exponents? What am I supposed to do here? Mainly, is this where I add them, or is this where I multiply them? Do we remember which one it is? This is where we add them together. So when we're doing polynomial multiplication, you're going to be generally you're going to be adding the exponents, okay? Hopefully you all got that. You did your rules of exponents. You're comfortable with it. Then you should be fine on this problem for these types of work we're doing, right? So how's that going to manifest for us? Well, basically, we look at all sorts of polynomial multiplication problems, right? Monomial times a trinomial, binomial times a trinomial, trinomial times trinomial, binomial times monomial, binomial times binomial. There's all these different versions, and this is why many of your teachers have taught you many different ways of memorizing those different combinations. If you think about it this way, you can just take what I'm showing you and you can apply it to any of those problems. Binomial, 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 trinomial, monomial, trinomial, all of them. It works for all of them, and you don't have to memorize like all these different ways of doing it. Like FOIL. FOIL is one way of doing one particular problem, but it only works for that particular problem, right? So let's just start with an example here. So I've got 2x to the 5th times 3x to the 7th. Okay, so what do I have here? What kind of polynomial multiplication? Why does this not look right? Oh, because I didn't close my, there we go. There we go. That will format correctly now. Okay, so what do I have here? I have a monomial times a monomial. This is the easiest multiplication we can do. It's just a one-term polynomial times a one-term polynomial. So what do? Well, we multiply the 2 times the 3 to get 6. Then x to the 5th times x to the 7th, which is x to the 12th, right? We add those exponents. 6x to the 12th. Here's what's going to happen. No matter what polynomials you're multiplying together, binomial, binomial, or binomial, trinomial, or monomial, trinomial, and whatever it is, whatever combination of polynomials, you break that problem down into a bunch of these problems we just looked at, monomial times monomial. So if you do a monomial times a trinomial, you'll be doing operations like this 3 times. If you do binomial times trinomial, you'll be doing operations like this 6 times. Trinomial times trinomial, you'll be doing operations like this 9 times. So view the problem that way. When we get to the more complicated polynomials we're multiplying together, realize, oh, this just breaks down into a bunch of monomial times monomial problems, and these are easy. Almost always my students get this. Like, if I give them these, they'll do it. They're like, I totally get it. So all you have to do now is realize how to break these bigger problems down into a bunch of this. And since most of you are going to be comfortable with this, then you should be good to go. Okay, so now we expand. Let's give our formal definition. So to multiply polynomials, multiply every term in one polynomial by every term in the other polynomial. This is the true definition for polynomial multiplication. To multiply polynomials, multiply every term in one polynomial by every term in the other polynomial. Okay, that's what all of these really come down to. It looks like I'm off the screen a little bit. To multiply polynomials, multiply every term in one polynomial by every term in the other. Every way that you've ever had a technique that a teacher shows you for how to do a certain type of polynomial multiplication really just came down to a way of organizing this, making sure that you got every term in one polynomial multiplied by every term in the other. When we do FOIL in a few minutes, that's all it is figuring out how to get every term in the first binomial multiplied by every term in the second binomial. It always comes down to this. So let's take a look. Actually, let's see. My screen's a little, let's see, how am I going to change this? Sorry, my windows are kind of overlapping here. I can't see what I need to see. There we go. That should work. Okay. So take, for example, we want to multiply a monomial times a whatever, right? So let's say we've got 2x squared, and I want to multiply that by 3x to the fourth minus 7x squared plus 3x minus 1. And let's put an extra space in there. Okay, so I have a monomial times a 4-term polynomial. Okay, so I want to multiply every term in the first polynomial by every term in the second polynomial. Well, this is just the distributive property, right? All we have to do is distribute this into each term, and we have multiplied each term in the first polynomial by each term in the second polynomial. So that will be 4 monomial times monomial multiplications. So let's go through and do that. All right, so what have I got? 2 times 3 is 6. We're going to get x to the 6th because I'm adding those exponents, right? If there's any questions along the way, make sure you let me know. 6x to the 6th minus 14x to the 4th plus 6x cubed minus 2x squared. Okay, so we distributed this in, watched the signs, we multiply the coefficients, and then you add the exponents. That's what I did for each of these. It's just a monomial times a monomial, so you're multiplying them in. In this case, it's real simple because you're just going down the line. You're just distributing that 2x squared in. It doesn't, if you start with a monomial, it doesn't matter how big this polynomial is, you're just thinking about the distributive property. I'm just distributing this value through and multiplying everything out, right? Okay. All right, so then we get to, well, what about when we bump it up to binomials? And here's where you may have seen a thing called FOIL, and we'll go over it. Again, it's just a special way of helping you remember to get all the terms multiplied correctly. So FOIL stands for first, outer, inner, last, okay? If we're going to take everything in the first polynomial and multiply it by everything in the second polynomial, that's 4 multiplications we have to do, right? 2 terms in the first polynomial multiplied by 2 terms in the second. That's 4 operations we have to do. FOIL is just a way of helping you remember the order. First, so FOIL is first, outer, inner, last. So your first terms multiply together, your outer terms multiply together, your inner terms multiply together, your last terms multiply together. So again, it's monomial times monomial. We're doing 4 of them, and FOIL just helps you remember. So a lot of times people come to me and say, no, FOIL's totally different. No, FOIL is just a way of multiplying every term over here by every term over here. And it just helps you remember the order. So let's multiply these out. So I'm going to get, so when I do the first, 2x times 5x is 10x squared. The outer is going to give me plus 6x. The inner will be minus 5x. And then the last will be minus 3. So I took every polynomial, so I took 2x times 5x, 2x times 3, negative 1 times 5x, negative 1 times 3. So I got my 4 multiplications right there, okay? Now, notice these terms in the middle can be combined. Remember when we were adding polynomials? Remember this idea of like terms? Well, yeah, simplify them, right? The question comes, should I simplify this? And when students ask if they should simplify this, they're kind of just asking like, can I be lazy? No, just of course you should simplify it. You should always simplify a thing if it should be simplified or if it can be simplified, right? So this becomes 10x squared. So 6x minus 5x will become plus x and then minus 3. So here is your final answer for how you multiply those polynomials together, right? We combine the middle term and we do this. So what we just did, we have 3 lines here. One was just the original problem, but we have 3 lines here of polynomial multiplication. That's how we do our polynomial multiplication. Just for a bit of a preview, next chapter, which we'll do like next week, we'll be doing this backwards. You start at the bottom and you work your way backwards. That's called factoring. So if we start up here and we move down, that's called multiplication. If you start down here and you move up, that's called factoring. Factoring's harder. By the time we're done with factoring, you'll all be pros at polynomial multiplication. In fact, most of you will pick it up pretty quick. But that's where we're going, is how to do this backwards. That's a harder direction to go, is to work backwards. But the polynomial multiplication, you just follow directions. Every term in the first one multiplied by every term in the second one, and you're good to go. All right, what about when it gets complicated? What about if we've got a binomial times a trinomial, right? And in this class, trinomial times trinomial is about as hard as it's going to get. 3-term polynomial times 3-term polynomial. The first couple times you do that, you might be a little intimidated and you're like, man, this is hard. But once you've done a couple of them, you're like, okay, actually I can move through this really quick. They're not nearly as bad. So let's do a binomial times a trinomial. So let's make it 2x squared minus 5x plus 1 over 3x minus 1. Okay, so there's our, it's a trinomial times a binomial. All right, so I have to make sure I get every term multiplied in one polynomial multiplied by every term in the other one. That's going to be 6 multiplications I have to do, right? 3 from here times 2 over here, that's 6 total. So just go through it. Here's how I generally would do this problem. If it's me, and you can do this either way you want. If it's me, I kind of like to put the binomial in front, but it doesn't matter. Remember, that's the same thing. So you're allowed to do that. So I would probably, just for, I think it's a little cleaner. It doesn't really matter. But I would make this 3x minus 1, and then make this 2x squared minus 5x plus 1. See, all I did was change the place of the factors. They're the exact same factors. I just wrote them in a different order because the way I think about these problems, it's a little easier this way. So here's what I'm going to do. If I want to multiply everything over here by everything over here, I'm first going to take the 3x, and I'm going to go through and multiply everything here by 3x. Then I'm going to go back and take the negative 1 and multiply everything here by negative 1. Then I will have my 6 multiplications that I need to do. So let's see how that works. When I go through and do that, I'm going to get 6x cubed minus 15x squared plus 3x. Okay, so that's the terms I get when I multiplied everything through by 3x. 6x cubed minus 15x squared plus 3x. Right. Now I'm going to go through and multiply everything by negative 1. So negative 2x squared plus 5x minus 1. Okay, But notice how we have some like terms here that can be combined. We have some simplifying that we can do. Well, then of course we need to do it. So there's only one x cubed term, so we've got 6x cubed. Okay, but notice I've got negative 15x squared and negative 2x. So let's see, that would give me negative 17x squared. And then I've got a plus 3x and a plus 5x, so that gives me plus 8x. And then I've got my minus 1. So that should be our final answer when we're done here, right? See, no more like terms. Nothing more can be simplified and added together. So that's fully simplified. Now, be careful. Remember when I said when we're adding and subtracting polynomials, your variable should not change. People try to change the exponent when they're adding and subtracting polynomials. They shouldn't change in that case. Notice they did here because polynomial multiplication is a totally different game. So see how there was no x cubed term in our original problem, but we do have an x cubed term in our final problem? That's because it's polynomial multiplication, different than polynomial addition or subtraction. Okay, it works differently. So let's take a look at a couple homework problems. So we've got, let's try this one. Okay, simplify the expression to a polynomial in standard form. So we got to make sure you can see it. So this is like the problem I just did. I'm going to go through, multiply everything by x, multiply everything by 2. So let's take this problem. So let me work through this one. X minus 2, and then what was the other one? 2x squared. No, x squared minus 2x minus 9. X squared minus 2x minus 9. Okay, we want to multiply this out. So first I'm going to go through and multiply everything by x. So that's going to give me x cubed minus 2x squared minus 9x. Now I'm going to multiply everything by negative 2, giving me negative 2x squared plus 4x plus 18. And then let me just double check. Oops, I have a typo. This should be an x cubed, shouldn't it? X cubed minus 2x squared minus 9x negative 2x squared plus 4x plus 18. Okay. Now we just simplify what we have here. So we have an x cubed. Let's see, I have negative 2x squared and another negative 2x squared, so I have minus 4x squared minus 5x, negative 9x plus 4x, and then plus 18. So let's see, x squared, oops, I keep doing the 2 instead of the 3. It should be cubed. X cubed out in front. I keep hitting the 2 on accident. There we go. So let's see, x cubed minus 4x squared. X cubed minus 4x squared minus 5x plus 18. Minus 5x plus 18. So I forgot that this book does it. This is what's oftentimes known as the box method. It's the same thing. So this is actually a good example. I can show you. Let's see. I might be able to show them side by side. Let's see if I pull this out. Wonder if I can get that. So this is how I did it. This is how you see it in books a lot because they're trying to save space and also it's easier formatting. This is called the box method, where you put things in a box. Right, it gave me credit. Yeah, right. So I got it right. It gave me, so do it in the box method. But do you notice it's the same exact work? I had 6 multiplications up here. They had 6 multiplications down here. And look, we can track each one. Here's the x cubed. Here's the negative 2x squared. Here's the negative 9x. Here's another negative 2x squared. Here's the 4x. Here's the 18. And then you just combine like terms just like we did. So, you know, I get, well, people will argue with me like, no, the box method is different. It's a different way of doing math. No, it's the same mathematics. You're putting your stuff in a box, and I'm writing it on a line. It's literally the same exact procedure each time, right? That's like saying if you wrote a list sideways and the person next to you wrote that same list but vertical, where you're like, these are two completely different lists. No, they're identical. It's just one of you wrote it horizontally, one of you wrote it vertically, but it's the same actual stuff. Okay. So there's that. Oh, I don't want to do another one of these. Let's do, so multiply polynomials level 2. So here's trinomial times trinomial. It's the same thing except you're going to have 9. So like if we look at the solution, your box is just 3 by 3. But if you do it the way I showed you in class, you'll just have all these same values, but they'll be written in a line. Honestly, it doesn't matter which one you do. It makes no difference at all. If one of these methods is better organized for you, you use that one, okay? So it's the same thing. And of course, there's the help videos in here that you can watch. I forget what level 3 was. Oh, yes. Level 3. Okay. So this one confuses people for 2 reasons. There's 2 reasons I see people get confused by this. So they start, here is very important thing to understand. So let me take I knew I was missing something. This is really important because students make this mistake all the time, and then we teach them not to do it, and then they get to pre-calculus and they start making that mistake again. And then we teach them not to do it, and they get to calculus and they start doing it again. And in all these advanced classes, we're constantly teaching people not to do the mistake I'm about to show you. So here's the idea. Let's say we have (2x plus 1 squared). Okay, it is very common, I see this all the time, for people to say, okay, 2x plus 1 squared, well, wouldn't that just equal, so this is wrong, by the way, what I'm showing you. 2x squared plus 1 squared. They go, yeah, don't you just square each piece? And the answer is no. No, you do not do that. This would come out then, if we did that, this would come out as what? 4x squared plus 1. Okay. So this is what people do. They go, okay, I can square this by just squaring each piece in there, and then I get this, right? Nope, that's wrong. Do not do that way. So you go, okay, well then how am I supposed to do it? Well, here's the trick, and it's weird because students will literally look at this written this way, and they'll have no idea what to do, and they'll be like, I've been trying to remember how to do this problem. What is going on? And I say, just write it out in its multiplied form, not written as an exponent, but just write it in multiplication form, and then they instantly go, oh, now I know how to do it. So the key is to write it like this. What does 2x plus 1 squared mean? It means 2x plus 1 times 2x plus 1. So 2x, if you write it this way, 2x plus 1 times 2x plus 1, students will go, oh, I know how to do this problem. They go, this one I don't know what to do, but this one I know how to do. I'm just going to use my FOIL. I'm going to do my 4 multiplications to figure out what this is. Right. 2x plus 1 quantity squared, you just rewrite it this way. And then you go, yeah, I see how to write it. Okay, so let's see what happens. This becomes, so 2x times 2x is 4x squared. Then we get, for our outer, we get plus 2x. For the inner, we get plus 2x. And then we get a plus 1. So when we simplify all that, we get 4x squared plus 4x plus 1. And I'm about to run out of room here. So I will have to go to a different line. So see how this is different? Sure, our wrong one and our right one. So I'm going to write, in this one I'm going to write yes. So we know which is the good one and which is the bad one. See, the bad, the bad way of doing it has a 4x squared, so does our good way of doing it. The bad way of doing it has a 1, so does our good one. But notice that our right way of doing it has a 4x middle term, and this one doesn't have a 4x middle term. right? It's not like, oh, well, it's kind of close. No, it isn't. It's completely wrong. Okay, so make sure that you think of it this way. So that's part of the key to the problem I just showed you. There's two things going on here that confuse students. The first is this. When you have a factor raised to a power, write it out in the expanded form. Like it's literally like it's like someone turned the light on in a room. Like you're trying to work in a dark room when it's in this form, and they go, you got to tell me how am I supposed to progress in this? And you go, oh, write it out this way, and then boom, it's like someone turned the light on, and all of a sudden they can get all their work done, right? So just think about writing it out in that way. The other problem here is, oh, we have a cubic. What's that going to do? So let's work through that one. So 3x, I probably won't work through the whole thing because I don't think you need me to go through all those steps, but I'll tell you how to set it up. 3x plus 1 cubed. 3x plus 1 cubed. Okay, 3x plus 1 cubed. So first step, write it out in the expanded form, meaning this becomes 3x plus 1 times 3x plus 1 times 3x plus 1. Okay, so write it out this way. And then students go, okay, I get that. So we don't have it in the exponent form now. It's now written in this expanded form, but there's 3 of them. What do I do? Well, what if I gave you 3 numbers and said to multiply them? What if I said, I want you to multiply the numbers 2, 3, and 5 together. What would you do? You'd multiply 2 of the numbers together, and then you'd take that answer and you'd multiply it by the third, right? So you'd go, oh, well, 2 times 3 times 5, that's 2 times 3 is 6, times 5 is 30, right? But for some reason, students don't do that when it gets to polynomial multiplication. They say 3 things they're supposed to multiply together, and they're like, I don't know. We didn't learn how to do that. Well, you just do it in steps. You multiply the first 2 things together, and then whatever you get, you multiply by the third thing. So you just break it down into multiple steps, and it's not bad. So yeah, this is kind of a longer problem, but let's see the solution. See, that's what they did. So they wrote it out into the expanded form, and then what they did is they took these 2, multiplied them together to get this, and then this is just a binomial times a trinomial, so they used the box method, and then you combine your like terms at the end. Okay, so that's all you have to do for that one. I know it's like the stuff you're missing. Once you realize how to do it, it's super easy. Yeah, you just expand it. That's not hard. Students know how to do that. And then multiply 2 together before you multiply the third in. Oh, that's not hard either. It takes a little bit of time, sure, but it's not actually overly complicated to do. And then you've got your long division problems, which again, I think by using by watching the videos, I think you should be able to get it done. If you're struggling with it, talk to me, but I think you'll probably be okay by just going through and watching those. And let's see, that should be a lot of what we need, what's due by the next sort of round. So you have, what, in 3 days you have a bunch of homework due. I think we've covered all of this stuff, like I said, except for the long division, and can't really cover that in 12 minutes. That's like half a class to make any kind of sense of the long division. So watch the videos, make sense of them. Yeah. The 2 things you have to look out for when you're doing these long division problems are how to write the remainder, but they show you right here. You write the remainder, like how to do that. It'll show you in the video, right? And then what's the last one again? Yeah, so you've got a remainder, and sometimes you have a missing term, and you have to account for that missing term. Other than that, the polynomial long division just kind of becomes automatic. So that's kind of wrapping up that chapter. I don't really want to start the next chapter yet because we're not getting into it yet. So for the remainder of class, is there anything I can help anybody with? Does anyone have any questions that we can discuss, that we can talk about and go over some stuff? No? Okay, well then I think you're largely ready to go. I do have office hours on Monday. Remember Zoom office hours Monday. The ones that used to be on campus are Zoom office hours now. So feel free to come get help from me, and we can look into that stuff. So if you need help. Otherwise, I'll keep Zoom open in case anyone wants to hop in there and ask me questions. Otherwise, I'm going to shut the YouTube stream down, but I will leave Zoom open until the end of class so that you can come speak with me if you want to, okay? So if you have questions, come talk to me in Zoom. Otherwise, I'm shutting the YouTube stream down.